Okay, let's go for the section number 9, analyze. So we're going to talk about trade fastener subject to an initial tensile force and the external loading analyze. So this type of thing is going to be happen like this anyway, as shown in the figure 8.12 anyway. We have the workpiece looks like that, and when we fasten together with the bolts and nuts, look like that, and we have an external force of P applied on it, and when we tie the bolt to exert an amount of force of F sub I to be enough to just sustain in it anyway, to in order to avoid the P is to be lower than the F of sub I anyway. Then what I said in here, the connections, okay, that what I the first sentence here, the connections of the workpiece by trade fasteners as shown in figure 8.12 may involve with the initial tensile force of F sub I due to the torque tighten the bolts and nut together and the external loading of P applied directly to the workpiece. Then these type of trade connections is widely used with sealed connections such as pressure vessel connections. The trade connection remains when the initial force of F sub I is equal or greater than the external force of loading of P. Therefore, the bolts to be proper tightened to provide corresponding initial tensile force of F sub I in order to keep the trade connections remain. The analysis required torque to provide F sub I can be done as shown in figure 8.13 then. So therefore we got to provide the F sub I to be greater enough to provide the tighten of the workpiece to stick together. Otherwise we're going to cause the leakage between the two pieces of the workpiece anyway. As shown in the figure 8.13 anyway, we have figure A, B, and C respectively. The subscript of B stands for the bolt and C is going to be workpiece respectively. We're going to have a figure A anyway. This is going to represent the elongation of the bolt due to the initial tensile force of F sub I. You can imagine we just apply the force of F sub I. The bolt itself going to make elongation anyway. That's what it shows up here. The F sub I going to force the bolt to be the delta sub B respectively. And then at the same time, when we just tighten it up, the F sub I going to force the workpiece to shorten down with the delta sub C already. Look like that anyway. When we just put these two figures together, A and B, we're going to have a figure C respectively. We have the inclination or the slope of theta and alpha respectively. So therefore the combination of figure A and B just apply to it. It said in here typically the stiffness of the workpieces is greater than that of the bolt. Therefore the elongation of the bolt is greater than the shorten of the workpiece. So based on the figure, I'm sorry, this one is changed to be 8.13. It's revealed that the angle of alpha is greater than the zeta, and the line AC may have a slope to be negative due to the shortening of the workpiece. Of course, right? Figure C look like that. And then let's introduce the K sub B, the stiffness of the bolts, and K sub C, the stiffness of the workpiece. So therefore, based on the figure 8.13, we're going to have a tan theta is equal to F over F of sub I over the delta. B is equal to K sub B respectively, and we cross multiplied it. We're going to have equation 1. At the same time, we're going to have figure 8.13 again. C, we're going to have equation 2 respectively. And if we apply the stress and strain relationship, we're going to have equation 3 respectively, F sub I. And then based on equation 1 and 2, we just equate it to each other. We're going to have the representation of K sub B equal to E sub B times A sub B over L sub B respectively. And then from equation 2 and 3, we're going to have the same thing happen. It's one more time again, K sub C equal to E sub C times A sub C over L sub C respectively, where K sub B can be the stiffness of the bolts in the workpiece respectively. E sub B and E sub C is the Young modulus of the bolts in the workpiece respectively, and L sub B and L sub C is the length and the thickness of the workpiece respectively. And then let's make some notes on it. L sub B equal to L sub C when there is a gasket and the gasket thickness respectively. L sub B equal to L sub C plus L sub S. Okay, So the gasket is going to be L sub S, look like that, anyway. And then A sub S is going to be both cross-sectional area, and A sub C is going to be equal to pi over 4 d sub E squared minus d sub E squared, just like that, okay? So therefore, this is the case for the details of that, anyway. And then when we just apply a gasket on it, okay, the gasket is going to be like a washer, things like that. We're going to have a K sub T respectively, going to be equal to E sub G times A sub G over L sub G. And then, so therefore, the total stiffness is going to be 1 over K sub T, going to be equal to 1 over K sub C plus 1 over K sub T, okay? It's going to be the total stiffness, look like that, okay? And then, so therefore, this is going to be important thing. So it's said in here, okay, when the external tensile load of F sub E as shown in figure 8.12 is subject to the thread connection, the loading on the boat increases, but the loading in the workpiece decreases. Is that right? Okay. When the external tensile loads F sub E keep increasing until the compressive force of the workpiece equal to 0. Therefore, the connection will be separated or leakage, okay, or the case of the pressure vessel threads connection, okay. So let's say F sub E external tensile load causing the connection with being separated, F sub O, right? F sub I going to be initial tensile force in the boat, things like that. So therefore, to avoid separation or the leakage, things like that. So therefore, the F sub I going to be equal to F sub O, K sub T over K sub B plus K sub T respectively. So if without gasket, the K sub T gonna be equal to the K sub C, things like that. And then if the external tensile load F sub E should be lower than the external tensile load causing the connection being separated, or F sub O. The F sub O is recommended to be 1.2 or 2 times of F sub E. Okay, that one I just put in the bracket already. Okay, then Q is going to be 1.2 to 2 times, things like that. I just put there in the equation to put the simplification on it, and then therefore the F sub T going to be equal to F sub I plus F sub E, things like that, okay. And then total compressive, okay, load on the workpiece, okay, going to be minus on that F sub T, okay, F sub I minus F sub E, things like that, right? And then therefore the thread connection, this one is important thing, okay, that what I put the both letters. Therefore the thread connection will be separate or lead for the case of pressure vessel thread connection when the total load pressure loading applied to the workpiece or F sub TC equal to 0, or this one F sub TC is equal to 0, gonna cause a leakage anyway, this one, right? So therefore, we have some kind of like example 8.3. This is the case of the not pressure vessel. Anyway, this one is going to cause some separation. There's no force acting to it anymore. You may have a look at it by yourself, things like that. Okay, it's going to be very simple, things like that. And then another one is point 4 is going to be a pressure vessel. You may go for it, and 8.4. Okay, very straightforward on that. Okay, and then section 10, okay, trade connection subject to eccentric load and combined straight in trade connection. Okay, this one trade connection may subject to other types of loading, such as in the case of the eccentric load and the combined loading. This line may use the simple same principle as of the rivet connection as shown in section 4, section 5 in chapter 7. That what I talked is over already. Okay, it's exactly the same. We just do the same calculation that what we have done before. Okay, that's what is going to be the lecture that what I'm going to done on the design of the trait anyway. So okay, I have some kind like problem set, okay, for you guys to do on it. For number one, very simple, very good practice on it. Number 2 and 3, number 4, 5, things like that. Very good example. Like number 6, we changed the rivet should be the boat, things like that. Number 6, okay. I will show you some example on it. And then number 4 is going to be pressure vessel, things like that. And you may practice on it anyway. Okay, it's going to be it for the trade connections. Okay, for my lectures anyway. Thank you.